So I'm going to write out the equations for conditional models, and I'm going to start with the general level 1 model. So we have yijk, and then we have the intercept, which is pi 0 jk. And then if we have a level 1 predictor, we're going to have a pi 1 jk times, and this now gets an a 1 ijk, so the first level 1 predictor. If we have a second level 1 predictor, it's going to get a pi 2 jk times a 2 ijk, and so forth. And I'm going to write out this for a case of a pth pi p jk times a p ijk, and then we have an error term of eijk. So you see consistently everything gets a jk, the variables, not the variables, the predictors get an ijk, while the pi's that are associated get a 1, 2, 3, and so forth. Then for the general level 2 model, you need as many level 2 models as you have predictors in pi's in your level 1 model. So I'm only going to write this out for pi 0 jk and pi 1 jk. And what you would get here is a beta 0, 0k plus a first level 2 predictor of the intercept of pi 0 jk is a beta 0, 1k times x1 jk, plus, let's say we have a second one here, beta 0, 2k x2 jk, and then this continues on all the way to r0 jk. And then now when you notice the difference between the beta 1 jk and the pi 1 jk and the pi 0 jk, that's all the difference here. So the 0 is the first indicator, the first number of those betas here, and all the way up to the 0. It doesn't want to draw here. So we're going to do the exact same thing and pretty much copy the equation, except changing the first 0 to a 1. So it's beta 1 0k plus beta 1 1k x 1 jk. That's the same predictor. Beta 1 2k x 2 jk. Again, the same variable here. And then r1 jk. So just to mark this in green here as well, we're getting the 1, the 1, the 1, the 1. And finally, I'm going to write out the general level 3 model. And now we need one for each of the betas. So this is where things are getting even more complex now. So you would get a beta 0, 0k, a beta 0, 1k, a beta 0, 2k, a beta 1, 0k, beta 1, 1k, beta 1, 2k in our case, and then so forth. Actually, as I mentioned before, I skipped writing an equation for the pi 2 jk, so we have to stop somewhere. But the general equation for the beta 0k now is the gamma 0, 0, 0 plus the gamma 0, 0, 1 w1k. If we have a level 3 predictor of the intercept. Now I have to erase this because we have a gamma 0, 0, 2 W2K, and so forth, all the way to a U00K. So I'm going to mark the numbers and the indices that stay the same. So it's beta 00. So it's gamma 000, gamma 001, gamma 002, and so forth. Okay? And that way I can now copy that equation if I have the same predictors in there. And all I have to do now is a 0, 1, 0. And then you can just move forward. Gamma 0, 1, 2. All the way to get the U01K. And then this is a gamma 02. Gamma, now you see I already made a mistake here. Hey, I'm erasing. This was wrong. So let me 0, 1, 1. 0, 2, 1. Gamma 0, 2, 2. All the way to a U02K. So let me mark this again. I'm going to use yellow now for the ones that we have here. We have 0, 1s here, and then 0, 1, 2 counting up, 0, 2 here. And now we're going to move into the beta 10K. So we're going to get a gamma 100 plus a gamma 101 plus a gamma 102, and so forth until we get to U10K. The next one is a 110, gamma 111 plus gamma 112, and hopefully we get them all right, 011K. And then we have gamma 120 plus a gamma 121 and gamma 122. And you can see how this just keeps going. And I think some of you wrote out, last week when we had the PEC article, that that they're all predictors in each of the equations of the intercept and the slope. And now you could go ahead and you could just delete certain things if you know that certain interaction effects wouldn't be there. For those the 3-level models, I would strongly suggest to keep them this way, or start writing them with summations. If you wanted to create a mixed equation, it just gets incredibly complex and complicated, and it's easy to make mistakes. But this is it. It's tedious, but it's the only way to write this out correctly.